So, off you go.
Yeah. So you like strategy games, huh?
I do.
Yeah.
But that's not going to go anywhere with me because I don't know any.
Well, we made Immune Defense. I decided to make it a strategy game because there seemed to be no limits in what kids could remember.
Yeah. Well, if they've got the the drive to find the next level, then they're going to remember what they need to remember to get there, aren't they?
Yeah.
So they're going to know that they need a T cell or a B cell or a macrophage because they're going to want to level up.
Yep.
And so they're going to remember that. So
that's the plan, and I think they do.
Yeah.
The kids we tested on could even spell macrophage.
Cool.
Yeah.
That's really nice.
Yeah. I was surprised.
Yeah. So how are you going to build more levels into it?
Well, we're starting with just a macrophage and a neutrophil and some antibodies. And so there's a lot of interactions you can do with just that.
Yeah.
Using the right antibody or not wasting time with an antibody because this bacteria is easy to get. And we'll build lots of different, scenarios where the bacteria are here and there. We've also got a lung level where you have a maze to get around.
Okay.
Then, stretch goals, we can add more cells. We can add those natural killer cells.
Yeah. And are you looking for T cells later as well?
Yep. That's another stretch goal. We can do T cells. So if we just have NK cells, we can start talking about viruses.
Yeah.
And cancer. And in times when you need to actually kill a human, your own cell, that's a natural killer cell. And B cells and dendritic cells and natural killer are all part of that first stretch goal. So we have the ability to target cells that are infected with the virus. Yep.
So the nice thing about what you've got at the moment is you've basically got polymorphs, macrophages, or neutrophils, polymorphs, macrophages, antibodies, and then the next thing is NK cells. So they're all part of the innate immune system. So what they're going to learn about is the most primitive part of the immune system first, which is the bit that came first, evolutionarily. That's the bit that came first. And most animals on the planet only have those, So it's really only the vertebrates that get into the higher levels.
Yeah.
And so then when you start adding B cells, then you start stepping up a level evolutionarily as well as the levels within the game. So in actual fact, you've got biological relevance because you're moving up the evolutionary scale. As you're adding more levels, you're becoming more sophisticated immunologically.
Yeah, it's true.
And these are all those things. These T cells and the B cells are the things that you need to target to vaccinate.
That's right.
And so then you can bring that into the game too.
Absolutely.
Yeah.
The other nice thing is that the macrophages are like the core hero, and the B cells and the T cells, they're not only just the more advanced part, but their role is to make macrophages better killers.
Well, see, this is the really interesting thing. So when I first started in immunology, everyone ignored the innate immune system because they went, that's the primitive immune system. But it's really clear now that these early components, these primitive parts, if you like, are actually absolutely required for the required response. So they're critical to generate T's and B cells, and everyone ignored them.
Huh, that's funny, because by the time I learned it, no offense intended, that it was clear that if you didn't have a MAC to eat the bacteria in the first place, if you didn't have the dendritic cell to bring it.
Yeah, but it's not just that now, but you need the MACs to get the T cell response as well. So they do that. They do those primitive things, if you like.
Yeah.
But if you don't have them doing that, and if you don't have them sending the danger signals to the acquired response, then you don't get an acquired response.
Ah.
So they're critical for, they're like the sentinels, if you like. They're the ones that say, we've got a problem here, and then they're the first line of defence.
Yeah.
But they tell that acquired response that there's a problem. That it needs to start fixing.
Yeah, we have put that into the design. So T cells are a stretch goal, but we have the design for them already.
Yeah.
So the player has a cell, has a macrophage, and you need to put your proteins on the macrophage that will activate the T cell. I believe it's the B7s that you put on the Mac. Yeah. And so the T cell will only be activated if it sees first the signal from the Mac, but then also the B7s. So we have that dual signal that's required.
So it's biologically accurate.
Exactly. Biologically accurate.
Yeah. That was invented by an Australian, the two-signal method.
Oh, really?
Mechanism, yeah.
Go Australia. Who was it?
I can't remember his name.
I know. tune in next week.
Yeah, no, I can't remember his name.
That's awesome.
Yeah.
But it's a key mechanism that I really wanted to make sure I got in there.
Yeah.